Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 15 should come up as soon as you log on. I only gave you one problem today because I want us to get straight into the lesson. Today we are moving on. So the problem is compute the standard deviation. And it reads, Mr. Hughes asked 5 students how many hours of sleep they got last night. Response were 4, 8, 7, 10, and 6. Find the standard deviation. I'll give you some time and go. All right, do me a favor, share with your neighbors, see what you got. This should be done by now. And we'll have Austin T get us started with the process. All right, tell me what you write. Austin T, go. Pop them out, Carter. Go. Tell me what you write. And we find the mean or X bar or mu. And what you get for the mean, Araceli? 7. Hands if you got 7. Looks about right. So we take that and we're going to subtract from these numbers. And we got what? Daeli, go. First one is -3, -1, 0, 1, 3. Hands if you got that. What do we do from there, Austin S? Fermat. And you got what, Mia? Go. 1, 0, 1, and 9. What do we do next, Vianney? The mean again, or the X bar? And you said it's 4? All right, hands if you got that. And from there we find the sigma in low cap for Greek, which stands for what? Standard deviation. So, square root of that, everyone, you got 2. Hands if you got that. All right, send that in. Copy the agenda, please. Warm-up number 15, proportions and percents. Tonight's home play, only 9 problems, only. But if you notice, I only gave you one prompt for the warm-up, so like that, I'm trying to make time for the end of the period so you can try and finish the home play in class. Let's go. About 10 apples. Pretty good, yeah? Talking about apples, let's go. All right, code to access your home play. 52 TBG. 52 TBG, write that down. 52 TBG. 52 TBG. And for those of you that were socializing instead of copying the agenda, it's on your screen. All right? Huh? I'm what? Let's go. I got this, Lourdes. So, you should have completed the data with the update, so go to Canvas, turn that in, please. And also, your assigned progress, turn that in on Canvas as well. Give you some time, then a Cornell note, get a Cornell note. And by the way, tonight's home play looks like something like this. Yes. Set up a Cornell note, please. You do need a FAIR model. Like I said, we're going to go expeditiously through this session. I'm just trying to retrieve information that you already covered. Those of you that were with me last year or some previous years, you'll see how it starts kicking in once we do the practice for this. All right, here we go. Our objective for today: I can solve multi-step one-variable equations, proportions, and compute percents. So, the main idea is one-variable equations, and we are going to be touching on proportions and percents. Now, one main reason, I don't know if you guys noticed, let me mute the music in the back, as you were doing your research and looking through numbers and stuff like that, aside from adding and subtracting, what is the other main idea that came up? Percents, didn't it? Guys, in life, you guys got to get used to percentages because they're going to be here forever. When you buy a home, when you buy a car, when you get paid, you gotta know your percentages, or else they're going to rip you guys off. I'm just letting you know ahead of time. Now, I gave you a good exposure as to the other skill that you need to know. You need to know this. You need to know how to keep a budget, how to balance your bank account, how to balance yourself in regards to monetary balances, because if not, you're going to be overspending, you're going to get into debt and get into trouble once you get into college and, and all that stuff that happens after high school. You know what I'm saying? So with that said, one-variable equations, what are they? Write this down. One-variable equations are mathematical statements where two expressions are equal to each other and contain one unknown variable. One-variable equations are statements, mathematical statements, where two expressions are equal to each other and contain one unknown variable. Example: x plus 2 equals 25, 3x plus 2 equals 25, 12 equals y minus 8, 12 equals 4y minus 8, 2a equals 14, 2a plus 8 equals 14, negative 3 equals m over 4, and negative 3 equals m over 4 minus 6. Copy that. So, mathematical statements where two expressions equal to each other with one unknown variable. Let me go to the examples. Let me zoom in. Here we go. If you look at x plus 2 by itself, that is an expression. The 25 is also an expression, and what do they have in common? That they are equal to one another. What else do you notice on this equation? That it has what? Only one unknown variable. Same thing with this, same thing with this, this, and this. Pretty straightforward? Yes. Okay? Once again, this is just, I'm trying to review. Non-examples. Don't copy those yet. We have x plus 5 minus 25, 12 greater than x minus 8, x squared plus 5 equals 30, 4x plus 6 equals negative 2y. Talk to your neighbor, let them know why these are not one-variable equations. Why are those not one-variable equations? All right, let's see. Get us started, Mia. Why is this one not a one-variable equation? Dayeli, help her out. It has a variable. Alessandra. Aleshka. No equal sign. That is correct. No equal sign. So if it doesn't have an equal sign, this is also known as an expression only. That is correct. Now, obviously, this one doesn't have an equal sign. It has a what? An inequality symbol. That's why this one's known as one variable inequality. However, go to this one. Tell your neighbor why this one, look up, why this one is not a one variable equation. Now, we're going to come back to Mia to redeem question. Let's see. Why is that one not a one variable equation? Mia, go. Add what? More than one variable. This one has X and Y. So if this is not a one variable equation, what shall we call this one? Two variable equations. That is correct. My goodness, you guys remind me of me in kindergarten. Let's go to this one. X squared plus 5 equals 30. Look at the examples and look at that one. What makes that one not a one variable equation? Tell your neighbor, what makes that one? All right, Colleen, what? The square, that is correct. So technically it is just one x, but then it's split into two x's and it's still the same variable. However, when we solve it, we end up with two solutions. Therefore, that makes it a two variable. So hashtag have an equal sign, hashtag one variable, and hashtag no exponents greater than one on the variable. Moving right along, look up to the screen, writing utensils down. I'm going to cover some terminology that you need to know before we move forward. Pay attention, please, because what if I call your name and you need to give me a definition in your own words once I take away the definition? First term, look up. We're going to be talking about ratios. Ratios is comparing two quantities. Simple as that. But it's mainly represented in a fraction form. Look up to the screen. A ratio can be written as this, A to B. This right here, A with a colon, B, it's also A to B. Or in a fraction form, this is also pronounced A to B. Those are the three different ways of writing a ratio. What are we looking at right now? Ratio. Next one, proportion. What do you guys notice? A fraction equal to what? Another fraction. That's what a proportion is. When you have one fraction equal to another fraction, or, in other words, a ratio equal to another ratio. That is a what? A proportion. Next, we're going to talk about rates. Rates used to be posted here on the highways back in the 70s, 80s, and 90s. No longer that. When you guys are driving or going to places, they have the max speed. Is that correct? But before, the state of California had a little fraction on the side that said miles/hours, miles per hour. So a rate is a comparison of two different measurements, two different quantities, but measurements. Look at this. Miles is distance. Gallons is liquid. It's actually, like a weight of something. So it's two different things. So once again, rate is comparing two different measures. However, notice this one is 34 miles for 2 gallons. Well, if I asked you for the unit rate, you want to find out what it would be for 1 gallon. So that's what we call a unit rate. We reduce this to 1, so we have 17 miles per 1 gallon unit rate. Are we there so far? All right. Talking to your neighbor, let them know what a ratio is, what a proportion is, what a rate is, and what a unit rate. Not that I didn't call it. I called it. I told you guys. So talk with your neighbor, please. What is a ratio, proportion, rate, and unit rate? All right. Looks like Amelia's got it. Vanya's got it. But I'm going to go over it just so that I don't put people on the spot. Once again, a ratio is comparing two quantities. And it's pronounced A to B in words. A colon B. Or in a fraction form, A over B. Are we there so far? A proportion is basically a ratio equal to another ratio, a fraction equal to another fraction. A rate comparing two different measures in a fraction form, and unit rate is make sure one of those measures is to its unit, to 1. All right, we good? All right, moving right along, look up, don't copy this, pay attention, here it goes. Because you're going to do one just like it by yourself. It reads, the ratio of number of bones in the human ears to the number of bones in the skull is 3 to 11. There are 22 bones in the skull. How many bones are in the ears? How do I approach that, Mr. Q? Well, you need to first make a what? A ratio. Tell your neighbor if they give us the ratio already. Yes. How would I write that in a ratio form? 3 over 11. It's right there. 3 to 11. Are we there so far? All right. Here goes. Here goes the next part. Write your utensils down. Look up to the screen. Look up. Once you are given a ratio, you need to figure out what number corresponds to what. So you're going to read the problem and label stuff. So I'm going to read it. The ratio of number of bones in the human ears. Okay, so which of these numbers correspond to the ears? The first number that comes up, which is what? 3. 2, the number of bones in the skull. So out of those two numbers, which one belongs to the skull? 11. So now that we know what is what, now I can set up a proportion. There are 22 bones in the skull. Where would I write 22? Tell your neighbor, on the numerator or denominator? Logan, where? Denominator, that is correct, because this corresponds to the skull. So, what do I need to find out? How many bones in the ear? So I write X. Now, taking you back to algebra, let's see if you remember. 11 times X is 11X. 3 times 22 is 66, and the rest is history. Let's solve this. Divide by 11, divide by 11. X equals 6. My statement, there are 6 bones in the ears. 10 Q. From 1 to 5, I'll come to worry with this. All right, good. Copy this next one on your paper, please. Example 1B. Example 1B. And it reads, the ratio of red marbles to green marbles is 6 to 5. There are 18 red marbles. How many green marbles are there? Set up your ratio, then a proportion, then I want you to solve and write me your statement. Let me send you the screen so when you're done, you send me your notes. Woo-wee. Go. All right, help me set this up. Santi, what is your first initial ratio? 6 to 5, and that is equal to what? 18 over X. Hands if you got that. That is correct. So then cross multiply. Hands if you got X equals 15. And your statement, yes, there are 15 green marbles when there are 18 red marbles. All right. So we good, yeah? All right. Next, just to get some practice on proportions, look up. Don't copy that. Do we know how to cross multiply? That only works when we have a fraction equal to another fraction. I like to start where the variable is at, so I go 3 times m, 3m. 9 times 5 is 45. And last but not least, divide by 3. M equals 15. We did that, yes? All right, next. Look at that one. Walk your neighbor through that. Get your answer. Don't write it on paper. Do that on your noodle. Just talk it over to your neighbor. Walk them through that one. Get an answer. Write your answer on the screen. Y equals what? All right, answer. Quirin, what'd you get? Yeah, answer. Without writing stuff down. 9 is 20. Hands if you got that. That is correct. So we get the idea of cross multiplication, yes? All right. Look at this one. Don't copy it. Do we have a fraction equal to another fraction? Yes. So I start where the variable is at. So I go 2 times that. That gives me 2y minus 6 equals 42 plus 6 plus 6. 2y equals 48. Divide by 2, divide by 2. Y equals 24. Right? We good? All right, copy this one on your paper. Example 3b. G plus 3 over 5 equals 7 over 4. Send me your answer as soon as you're done with your work. Want to see your work? All right, let's see. Share with your neighbor what you got so you can get the show on the road. Answer, what'd you get? All right, let's go on the back to Mario. What'd you get? Answer. He said G equals 5.75. Hands if you got that. That is correct. Man, Mario, you're on the ball, man. Ooh-wee. All right, so we good with proportions. Look up. Let me set this up with a proportion. Write your utensils down, and it reads, Ralph Lau of Germany flipped the pancake 416 times in 120 seconds to set the world record. Woo. Find the unit rate. So first they want us to set up a rate. So turn to your neighbor, let them know what would be the rate that you would set up first. What would be the rate? That is correct. You would write 416 divided by 120. Is that correct? However, here goes. I'm going to pause the music. Look up, please, so you're going to miss it. They want us to find the unit rate. Question. Which one of these numbers would be easier to make it a 1? The bottom one, right? So that means this one, we need to find out what it is. So this is saying that this 416 is how many times he flipped the pancake, and this corresponds to seconds. So we want to know how many what? Flips in what? 1 second. That is correct. That's how we get a unit rate. And the rest is history. What is x times 120? 120x. 416 times 1 is 416. Calculators, divide by 120, divide by 120. X equals what? I'm waiting for you guys. 416 divided by 120 is 3.46. So this is flipped. So this is almost what? 3.5 times flipping a pancake in what? 1 second. Let's see, get your pencil. Go like this, pen. I'm going to cut 1 Mississippi, and I want you to flip it 3.5 times. Let's see. Imagine you have a pancake ready. Here we go. Imagine it's a spatula. It's a pancake. Here you go. 1 Mississippi. No, you guys are fired. So I would write, he flips a pancake 3.46 times in 1 second. 10Q. That's crazy, right? So that's how you do a unit rate. All right, look at it. Talk to your neighbor, let them know the process really quick before I move on for you to do one by yourself. Talk to your neighbor. What's the process for that? All right, here we go. Copy this, please. Example 4B. Just copy the last sentence. It reads, Corey earns $52.50 in 7 hours. Corey earns $52.50 in 7 hours. And of course, the instructions is to find the unit rate. Do that on your paper. Let me send you the screen. Send me your work as soon as you're done. Then we'll have Mario continue with our road to finishing this lesson. So, all right, send that in. You should be done by now. I need a statement to answer that for your unit rate. Tell your neighbor, what would you say for that one? Mario, pass someone. Oh, statement. Corey earns Austin T, help him out. Oh, you got it. $7.50 an hour. 10Q. Hands if you got that. Yeah, we got it, right? All right. So, send that in as soon as you can. Let's move on. Look up. Now moving on to percent. This is what we're going to close this session with. Percent is a word. It's a compound word. It can be broken into two words. Look up. Per and cent. Per means to multiply. Cent, everybody seen that before? Yeah, a cent. Hey, it's got 2 heads. Which means what? 0.01 or to have 1 out of 100 pennies. So when someone says, well, this is percent, that symbol, and somebody says 25%, this means 25 times 1 over 100. The reason, once again, I'm bringing percents in is because you saw percentages, and you're going to continue seeing percentages and everything you do from day to day. So there's a proportion that I like to use, which is this one right here. So copy that proportion, please. Is over of equals percent over 100. Copy that. Let me write it again. Is over of equals percent over 100. I'm going to be using this format so that I can find percentages given a situation. Example 5A. Pay attention. Look up to the screen, writing your utensils down. Focus. Ready? All right. So, 30% of 80. So, let me use my handy-dandy proportion. Is over of equals percent over 100. To fill this, I do blanks. I only write the 100, and I read the problem. Find what? 30%. Where does the 30 go? Tell your neighbor, where should I put the 30? Yeah, on top over here. And then it says what? Of 80. Where should I put that one? On the bottom. So if we don't have the top, we label that X. Cross multiply. Divide by 100. X equals 24. Very simple, yes? All right, copy that one so you can have it as an example, please. So example 5B reads 230 is what percent of 200? Fill your proportion. Let's see how you do with that. All right, looks like Cole and Carter are already done. They'll walk us through this problem and see how they do. Problem 5B. All right, let's see. Cole, what goes where? Top of the first one. On the bottom. And over here. Hands, if you got that. Looks about right. Yes. 230 is of 200. And so what do we need? We need to find the what? The percent. That's why we write X. So cross multiply. We got 200X equals to 230, 0, divide by 200. X equals, that's 150. Hands, have you got that? Percents. Yes? From 1 to 5, I'll come to right with this. We got it, right? All right, send me your work really quick. Let me send you a blank screen. It's going. And I'm going to stop the video right here. Those of you that are following on YouTube, make sure you go and do the practice. You can pause the video from the beginning. It's up on the first 10 minutes of the video. And we'll see you guys next time. Peace.